Hi everyone. Hi. I hope you're doing amazing. My name is Bharat, and welcome back to another stream I'm doing today. So today is going to be particularly very interesting stream, and it's a continuation of what I've been doing for the last 1 week, which is crash testing Hermes Agent. Today is something that was the most requested one, which is to use a local LLM along with Hermes Agent, and I'm going to step it a notch up by controlling a robot also with Hermes Agent that runs a local LLM. So earlier, if you've been following the streams, I have been using GPT 5.5 from Codex as the primary LLM inside Hermes Agent to do all the job. Now, what we're going to do is that today we're going to be actually installing a local LLM. In this case, I'm going to be using Gemma 4 model by Google. This is one of the state-of-the-art models that are currently there, and it can actually operate and is small enough to be run inside a Jetson or a Nano that I have. We'll be installing that. We'll be using it inside Hermes Agent, and we'll be controlling it. We'll be using it to control a real robot. In this case, that's behind me, which is running ROS. And we'll see how it works. And this is going to be a pretty long stream because we have a lot of things that we need to do. So just to give you a brief, I have prepared a set of lists that we need to complete today. So this is all the things that we did in the last streams, and you can see that most of them are completed by now, and we've gotten a pretty good understanding of what exactly is Hermes Agent, how does it operate, how do we even control. So yesterday we controlled a robot using Hermes Agent, and it was pretty amazing. It blew my mind as to how it was able to do that so easily. Now today what we're going to be doing is that we'll be using the same capabilities, but instead of paying an operator like OpenAI or Claude, we'll be using a local LLM, which is going to run right inside our device without any internet required, and it will do all the things that are that this GPT 5.5, and hopefully it's able to do that. So let's look at the list that we need to that we need to complete today. So the first thing that we need to do is that we need to check the installation of Gemma 4 by Google using llama.cpp. So llama.cpp is a provider and an interface through which you can install local LLMs very easily and sort of use it on your local machine. So we'll be checking that and installing that if there's any issues. Then we'll be running the Hermes agent with Gemma 4 model, which will obviously run locally. Then we'll also be running Codex with Gemma 4. So Codex, as you know, or Claude Code, for example, they by default run on their own sort of models on cloud. But there's a mode that we can also start where it does not need to use their own models, and it can obviously use local models like the Gemma 4 in this case. And then we'll be using the Gemma 4 model to run Codex, but operated through Hermes Agent. So I'm not directly running Codex, but I will be using Hermes Agent as a primary interface through which it will start Codex, and the Codex will be running on Gemma 4. And then to test all of this, we'll be giving it a long horizon task, sort of an end-to-end task, so to say, done through Hermes plus Codex using a local LLM, in this case Gemma 4. Then we'll test running ROS. And how does it operate with ROS, interact with ROS using the ROS MSpace server. And then what we'll do is that we'll operate and do all the tests with the real robot. So in this case, that's a UGV robot that I purchased from Waveshare. That's a company in China. And that's actually using Jetson or a Nano. So in this case, all the things that you see will be happening inside the main brain of the computer or a robot. And then we'll actually be testing later on as to how does it even work there. And then after that, we'll install another LLM in this case, once all of these things are done. In this case, I'm thinking to install a Kimi model because it's also gotten really good results in the benchmarks, in the public benchmarks. And I was very interested to see how does it perform in, everyday tasks, as well as these long horizon tasks, as well as these robotics tasks as well. So it would be very interesting to see how does Kimi model perform in this case. And then obviously we'll also be running Hermes Agent on that particular one thing on the Kimi model as well. And then we can also repeat all the other tasks as well. So I think it's going to be a pretty interesting stream this time because we'll not just be running vanilla models and installing it, but we'll actually be running our own models, and that's going to be very interesting to see how does it perform, where are some of the bottlenecks, and I'm sure there will be some issues as well, but we'll be fixing those issues on the live stream itself, because again, I'm here and I'm going to be doing this as long as not all the tasks are done. So let's start doing it. Yeah, perfect. So this is my terminal that I have opened, and I'll just quickly clear it. Okay, so this is inside my MacBook. What I need to do right now is I need to SSH into the Jetson or a Nano that is running locally on my network. So I'll quickly give it the ID password, and I think I should be logged in inside this. Perfect. So Hermes is actually installed inside this, and this is also the primary brain of the robot that I was talking about. So I'll clear this, and just to show you the Hermes installation, I'll type Hermes. And it might take some time to start and boot up. Okay, as you can see, the Hermes agent is again live, but one of the things that you see is that it's running on GPT 5.5. Okay, now that's okay, right? Like we tested this GPT 5.5 and it was able to give us very good results. Even yesterday, we actually controlled a robot, a real robot, using this thing, and it did a pretty good job in doing that, right? But today is going to be different, where we're going to be installing a local LLM. So this is not going to be GPT 5.5 any longer. We actually be seeing how can we install a local LLM into this. But before that, we do that, we will first need to check the installation of the local LLM that I did before this, right? So I actually installed. So let me clear this and SSH into this again into another terminal. So I actually installed a Gamma 4 model on this, and it's been a while since I've used it and tested it. So I have to first see that if even it is functional again or not. So the first things is that you see this llama.cpp folder. So that is where everything is stored. So if I go inside llama.cpp, you can see that all the things are there. And I believe that there was a place where I had all the models that were there. So let me just check that. Okay. So if I go on src and if I do ls, so these are all the, okay, yeah. So I think I need to start one of these model servers, and then let me just also find the commands on online, right? So I think that's the best way. um Start a llama cpp server on CLI command. Okay. So guys, like, I mean, I'm no expert here, so I'm also just trying to figure out everything by Googling it or by chat GPTing it. That's okay. Yeah. So model to path to your model. So we need to find the path to our model. So where is the model? So it's actually a gguf file that's there. So one thing that I could do essentially is I could do a tree command and grep the Gamma 4 model from here. Gamma, let's search if it's able to find it. It does find some of them. So Gamma 3 CLI, and it's actually embedded inside some of them. So is there a models? Yes, there is a models thing here as well, and then you see all the models here listed. So this is good. Now what we need to do, I don't know if all these models are installed or not, but I think the main thing is this one, Gamma 4 E2B IT 4-bit quantization KV cache model. That's the model that we're looking at right now. And what we need to do is that we need to start this model from the server. So let's do that. So yes, yeah. So let's actually, 1 second. Let me just put this terminal in the between so that we can use it very easily. And let me go cd dot dot, and then I'll actually do dot slash build. And what is the name? Build bin llama server. Okay, and then dash m, and then we need to mention the model name. So in this case it is Gamma for E2B. So this is the model. Okay, so it should probably load up the model now, and it's going to take some time to load it up. Let's give it some time. And the next thing that we need to actually see, we'll actually wait until unless it's done. We'll actually do how to, by the way, you can't see this, but it's okay. How to run Hermes agent on a local llama model CPP model. Let's test that. Okay, so there is a documentation that we found, and there's also this as well. Llama server path to your model. Okay, that's okay. Let's see this. Okay, so this is probably the documentation that we need to look at it, and it's still loading. Let's wait for it to load completely. I mean, it's going to be pretty exciting to see. how it does. So this is some of the chat templates that's there. Server is listening to this here. Let me give it a second. Yeah. Okay. Reference fullskill.md. Use the skill for local GGUF inference, quant selection, or Hugging Face repo discovery for llama.cpp. When to use: run local models on CPU, Apple Silicon, CUDA, ROC, or Intel GPUs. Find the right GGUF for specific Hugging Face. Build a Llama server or Llama CLI. Can I run Hermes using this? How can I run directly from this? Chat streaming, extracting available GGUFs from the repository. Um, what else is available here? This is not about how can we run the model. It's just a skill that's there for running the Llama 4 CPP here. The model is still loading. Let's give it some time to be able to completely load it. That's okay. Okay, let's see what is there. How do I get Hermes to list local models? That is okay. What is this providing? Hermes setup. Launch a Llama CPP server, run a GGUF version model using Llama server, ensure you dramatically scale up the context window as agentic workflows requires large context lengths up to 64,000 tokens to process system prompts and multi-turn token tool history for complex agent tools. Models like Qwen 3.6 is highly recommended over Gemma. Okay, we'll see that. We'll see that. Uh, if your model requires specific chat structuring like Qwen or DeepSeek, append the chat template file flag pointing to the correct Jinja template to ensure the calling syntax does not break. Configure the Hermes agent. You can configure Hermes agent either through its automated CLI setup wizard or by manually modifying its global configuration file. Okay, option A, interactive CLI wizard. Run the setup command in your terminal. Set the custom endpoint when prompted with the interface. Set the base URL to this or localhost this. So this is, I think, the API. This is exactly this one that we have. So again, I'm not sure if I'm able to if I'll be able to actually use this right now because it's still booting up and it's been like almost 5 minutes since it's been loading. So what is the context window in this case? So it's almost 131,072 context. That's quite a lot of context size. It's a large context size, honestly, if you ask me. But let me just come here and yes. So we'll actually be providing this as well, custom providers. So I think this is a manual configuration in config.yml. So that can be done here. So let me just again use another terminal to log in into this thing and come inside .hermes, and we should be able to see something like the config.yml. So this is all the things that are there, and there's also like a fallback model that it's created. Maybe I don't know about that, but that is okay. This is all in comments, but we could actually like provide different models here, custom provider. So where is the models that is mentioned here? So let me just do cat config this grep model provider. Okay, let's search for model only. Okay, so there's a lot of models that are there, and okay, our model reference models are this. Okay, so that is interesting. So we need to probably put something here. Where is models? So maybe just open Vim and do it. Vim config .yml, and then just search for model here, and then next model default this. Okay, so this is the first thing that's there, and it's OpenAI Codex base URL where to get it from, right? So what we need to do is that we probably need to make another insertion here where we could just say that where we could just say that um, yeah, so we could just say come here and custom providers, name llama.cpp. Under the custom providers, so there's no custom providers, is it, or is it like that? Custom, let's see, custom search hit bottom. Okay, so there's nothing like that. And okay, that is okay. Start the agent. Let's see if the server started. Hi. I don't know if it will started or not. Um, maybe I think what I should have done is that I should have probably ran it with like a lower context size, because it doesn't seem to be like probably work that well, because it's taking a lot of time. Like it's still not started. Starting the main loop. My only worry is that I hope this is not a browser endpoint, because I can't use the GUI right now. I need the terminal UI to be there. So I need to find how to do that. I think I found one Reddit post. How do you start your low llama.cpp server? CLI. Okay. Okay, yeah. So I had to start something like llama CLI, right? So I didn't have to start this server. So let me just stop it. I didn't have to start llama.server. What I had to do was to do llama CLI. Yes. So I probably have to do this instead of this to be able to see the CLI actually. I think this is better, because then people can see me as well as the screen as well. I mean, it's going to be a bit smaller, but that's okay. At least you can see the full screen. Okay. Out of memory, out of memory. So we can't do this. We probably have to do some hyperparameters with maybe like a less context window. Um, so let's do this. Dash C. Okay, let's do like 15,000. Maybe like let's do 15,000 or 10,000. I think let's just test it with 10,000. What is this? 1, 2, 3, 4. Let's do whatever that is. Let's see if it's able to do with 1,000. If it's able to do with 1,000, then it should probably be able to do with 10,000 also. Because one, okay, still it's not working. Allocating 557 megabytes on device 0. CUDA malloc failed out of memory. Failed to allocate CUDA 0 buffer size of this thing. Llama init from model. Failed to initialize with the context. Failed to allocate compute with PP buffers. Segmentation fault core dumped. Interesting. So we need to probably find a way out of this. Why is that happening? And how can we fix it? Okay, let me just search this, and let me just go on Chat GPT and see this. Guys, it's always this. What is the error? What is the error? And how can I fix? I am running it inside Jetson or in Nano, 8 GB, and I have almost 128 GB RAM. Let's see. Also, let's go on the Llama CPP documentation. Documentation for CLI. Let's go here. Llama.cpp, run local inferences in C++. That's not what we need. But Llama CPP tools CLI, that's what we are interested in. CPU affinity. So where's dash C? Show the list of models in the cache. Okay, now I just want a dash C. Context maybe. Yeah, so context size of the context default 0, loaded from the model. Okay. Oh no, this is not the one. So there's a lot of parameters that you can actually play with. I didn't knew that. This is actually a lot of parameters that are there. It's very interesting. What I'm interested in is what would make it work, honestly. Okay. So this is not working. Maybe like let me try with, I don't know, 512 context size. Would it still not work? It's like half of what I was trying it to. If it doesn't work, then it's probably something to do with the something other than like maybe memory running out. I don't know. Let's see what is it saying. The error is CUDA out of memory on your Jetson or Nano specifically while creating Llama CPP runtime interface. The model may fit, but your command asks for 10,000 token size window, 558. Jetson or Nano's 8 GB CPU memory is not shared between RAM. So first try with this. I mean, I did try with like a lot less, so it didn't work at all. So this is going to be interesting. I see 5 people, by the way. Hi guys. So this is still not working. It's still showing me some errors where it's not able to allocate certain memory. Let's see how can we fix this. Okay, let's try even smaller. In that case, let's try this. Okay, yes, finally. Okay, this is local LLM. Yes, it works. It works, guys. So what is the context size of this? So what we did was context size of 2048. What is B and UB? So we'll have to check that. Um, B controls the batch size. UB controls micro batch size. Lower values use less memory but maybe slower. Okay, so we probably have to use these parameters to be able to use it properly. Now let's ask it. What is ROS? Explain it to me. Guys, isn't it amazing that this is a local LLM model, thinking based models. It's outputting thinking tokens as well as it's giving me an answer, and it's running in real time, almost like you could not even read it. You have to like wait it across for it to complete to be able to read it properly. And this is just running inside a very small computer like a Jetson or a Nano. So it's pretty amazing if it's able to do all of this inside the local. There's no internet connection, nothing like that. It's just doing it, and yeah, it just gives us the answer. It's pretty good, yeah. Perfect. This is amazing. I like it. This is all running locally. Okay. Very good. This is amazing. Just imagine that this is all running inside a local computer. This is not a codex. This is not cloud code. This is just on local computer itself. So let's actually tick off one of the tasks that we have, right? Like some of the original tasks that I wrote out for this stream. So we were able to check the installation of Gamma 4 by Google using Llama CPP. So that's done. Okay, so the next thing that we need to do is that we need to run Hermes agent with Gamma 4 running locally. So one thing that you know is that yesterday what I was doing, I was running this Hermes agent. So even now this Hermes agent is not using any local model. It's using GPT 5.5 from my Codex account, right? So the issue with that is that it's good, but again, I mean, at the same time, you would want to use something local, and that was something that was the most requested thing. So I will actually be using this exact model, which is in llama.cpp, this Gamma 4 model, to run the Hermes agent. And that's going to be pretty interesting to see as to how does the thing perform in comparison to perhaps just GPT 5.5, which is like the frontier model. And this is a pretty small model, because if it's able to do that, then it's a pretty amazing, right? Like, why do we need even like to install these or use pay OpenAI, right? Like, we don't need to do that. Okay, pretty amazing. So this is good. It's able to do the things, and I think if we just put it inside this, if you're able to put it inside the Hermes agent, it should perform pretty well. I'm actually very interested to see if I can do maybe increase the context size. So the context size of 2048 will not suffice for something like a Hermes agent. What I need is not less than 64,000. And right now I was running on 2,000 context size, right? So that's not going to work. So let me try 80,000, for example. 80,000 context size of 80,000. I don't know how it's going to perform, and probably it's going to just not run. Okay. Let me just copy the command again here and then paste it. So this time I'm not going to do 2048. I'm actually going to be doing 70,000. It's a pretty step up from what I was doing, but if it's able to run 70,000, then because less than 64,000, it's not going to work, because there's again like there's enough tools and there's enough context that it passes on even before you pass in the first message, that you at least need 60,000. I think that's what they say. They say also that you can't run anything below 60,000 context size. Okay, it works. It starts pretty fast. Hi, what can you do? Let's test this. Okay, it's a bit slow if you observe it from the last one, but I think it's still pretty real time, I would say. At the same time, it's also like a lot of context that it has to store in memory, so we can give it to that. Amazing. Okay, I mean we could also even do 100,000 as well, and it should perform probably well in any case, right? Just imagine this is running on a small device. All right, let's stop this. And yeah, 8.7 tokens per second. What was the speed that we were getting here? 28.7 tokens per second. So it's like three times slower, but I think it's still decent. I would say it's still decent. It's not bad for like something like 70,000 tokens size. So let me try with 100,000 tokens this time. Let's see. So the maximum capacity that this model has is almost 130,000, but I'm gonna try it with 100,000 this time. Let's see. Probably I messed up the command, but that's okay. Let me see if this works. How does it do that? Okay, it works. So it starts. Hi. So it would be interesting to see what is the context size for maybe like 100,000 tokens in this case. Hi, what can you do? Or maybe let's ask it a more complex question. Hey, can you make a Python file which uses YOLO to do object recognition and provide me all the labels? Okay, I mean not very complicated, but still it should be able to do something like that. But let's see how does it do with code. And this is a thinking model, by the way, right? So it also outputs thinking token as well. So this is a reasoning based model that's there available. So I think this is even slower than the last one, but I think it's not bad for a local model running on a very small device. Okay, until unless it's completing, let's do one thing where let's try to see how can we install the Hermes agent. How can we install the llama.cpp inside Hermes agent so that we don't have to run it inside this? So let's ask this only. How can I have a local LLM Gamma 4 model on llama.cpp. Please guide me on how I can use that as the primary model. for Hermes Agent. Hermes Agent. Um, mm, okay. I don't want. Maybe let's just ask this first. Okay. Let's see what does it respond. In the meanwhile, it's running Gamma 4 here. Okay, it's outputting code for us. This is not bad. By the way, if you hear say hi guys, it would be nice to see something on the chat also as to how do you guys see it. Do you have any opinions or like what are your thoughts? So my GPU is so yeah, I'm using a Jetson or a Nano. I'm using a Jetson or a Nano. It's actually it comes with the GPU. It's by Nvidia, and it has almost 8 GB of memory, but it's pretty good. I think you can see this happening in real time. Thanks. Yeah. Okay, let's see if this responded something. So it's still looking up if it's still looking up the skills to be able to find how do we install the Gamma 4 model on Hermes Agent. So let's wait for it. And you see, right, like I didn't even ask it anything. This is the first thing that I've asked, and it's already consumed 55,000 tokens. So something like maybe like 2,000 or 3,000 tokens is not going to work at all. You at least need 100,000 tokens to be able to do anything meaningful, to be honest, with Hermes Agent. So that's why this one that's running right now, this instance is actually 100,000 tokens. So I'll show you here. So this is actually running 100,000 tokens, 100,000 context size. Yeah. So it's pretty amazing. Let me show you what I have. Jetson. I mean, it's inside a robot, so I can't pull that out. But I have this thing. So yes, it's around 250. I don't know if they've increased the price, but it is this device. But yeah, I mean, 67 tops, pretty good. I got it for like $2-3 only, but it's pretty impressive in terms of what's able to do. Not sponsored by Nvidia, by the way. Okay, perfect. So it's given us a response on what we need to do with exact things. Okay, let's read it and see what we do here. Yes, Hermes can use local LLM llama.cpp llama server as a primary model as long as it exposes OpenAI compatible API at V1 chat completions. Best path: use Hermes's local model picker. Start llama.cpp with enough context and tool call support. Example: so 64,000 is the minimum, but you were able to also test it with 100,000. So we'll start with that. Important flags: Jinja, required for all llama.cpp tool calling. Without it, Hermes may see tool calls as plain JSON text instead of actual tune invocations. Bash, so 64,000. Hermes is an agent with tool schemas and long context. The docs recommend to at least um, use 64,000 context for smooth agent use. If you use parallel slots with NP, remember llama.cpp divides the context across slots. For example, 64,000 NP4. 1 second. Okay, let's read some of the comments. Wait, if you're running this locally, doesn't it mean that you do not have to worry about tokens? Just the context window is what it means. Yes, exactly. So yeah, maybe like I was confusing the two terms, but what I mean by that is essentially the context size or the context limit of it. But the thing is that it has to fit it inside the memory. So the maximum context window that Gamma 4 supports is around 134K. But I can also run 134K as well. But the issue is that you see, like, it starts to throttle a lot, right? So this was the token. This was the speed I was getting, which is 28.7 tokens when I was running around 2,000 context size of 2,000. And then this is the speed 8.7 tokens when I was running like maybe 64,000. And let's see what is the speed. So 8.1 tokens. So it just keeps on decreasing if I increase the context size, because again it has to fit into the memory. But that's okay. Hi bro, how are you doing? Let me know where you're from, and it would be nice to. Thanks for joining us on the stream. Okay, let's see. So we were here. We were trying to see this, and basically it's saying that we need to run it with at least 64,000 context size, and we need to probably use all these parameters as well so that it calls all the tools appropriately. Yeah, so I'm using something like this. So GG. So if you go on Hugging, so I'll show you the exact model. Unsloth Gamma 4, right? So basically, Gamma 4 does quantization. So I'm using one of their models. It is this one. It is exactly this model that I've installed. Gamma 4 E2B ITGGUF version. So this is actually a yeah, this is 2.3 billion effective with 5.1 billion parameters embeddings. So this is the model that I'm using right now. I can't run anything over this. I think maybe 4 billion is the max that I could use. But I think this is also pretty decent. It runs pretty well, like on my understanding. Okay, pretty interesting. Pretty interesting. Let's see. So we need to start this thing. Let's actually copy this, and let me stop this, and let me clear it as well. So let's see what are the patterns here. Um, so host is this port 8080 path to your gamma model. So it is going to be models slash models slash this thing. 1 second. So yeah, can you give me a summary of what you're doing? Yes. So what I'm doing is I installed, so I'm using a local model. In this case, it's a Gamma 4 model by Google. I just tested it right now, whether if it's working on CLI or not. It was working pretty well. Now I'm actually connecting the Gamma 4 model with a Hermes agent so that everything happens on local inference instead of me using a GPT model or OpenAI model on cloud. So I'm trying to run this on a Hermes agent. So operate this on a Hermes agent instead. Okay, so the model is, so I don't, so let me just actually get the name of the model as well. So if I go on LS models, so these are all the models that I have, and maybe I want this model exactly. So I'll copy the command again. Let me copy it here and paste it here. And let me give the name of the model. So this is models slash gamma 4. So if I just type gamma 4, it should probably come. And let's increase the context window to 64,000 is decent. We can test it, but I want maybe like 80,000. And yeah, let's keep all the parameters the same. Okay, let's run this. Let's see how it happens. Okay, it failed. FA unknown value for flash attention. Okay, what was this parameter about that it gave? Jinga, right? So what failed exactly? FA was not found. Where is FA? Okay, so this is not there. Why did it fail though? So we'll probably have to see this. Required for llama.cpp tool calling without it Hermes tool calling is JSON text instead of this. Okay. So actually I have the documentation open. So why don't I look at this and search for what failed? So let me just do Control F and just do Jinga. Okay, yeah, so Jinja. Yes. So this is what it is. Default enabled, no, and this. Okay. Whether to use Jinja template for chat. Okay. Let me just copy this error and give it to Hermes agent only to figure out what is the error. And if it doesn't work, we're going to run it without it. But let me also just do one thing. Let me just go on Google and search this as well. Error. Jinga Llama CPP. What is the agent that you're talking about? Yes, this is a Hermes agent. So this is actually Hermes agent. And this is, if you've heard of OpenClaw, Hermes agent is pretty much similar to an OpenClaw, but it's like these type of agents actually have a persistent memory. So the fact that even if you start new sessions with it, you could like still like it grows with you, right? So essentially the idea is that there's a persistent memory, there's a lot of skills, there's a lot of tools that you can connect with it. And yeah, I mean, I'm just crash testing it for the past 1 week. So I'm also doing these live streams where I'm doing it live as well. So It's pretty interesting. It turns out that you can connect your Telegram, you can connect your email, and a lot of other things. I'm actually trying to control a robot, which I have a physical hardware on with the Hermes agent. But yeah, it's pretty interesting. It's better than like not better than, but like it's different from these codecs and other things that you see. Okay, the Jinja flag in Llama CPP activates the native built-in C++ Jinga templating engine to dynamically parse and render models chat structure. This engine built directly into the code base via Minja allow Llama CPP server. So what do I do? Okay, so I just have to do Jinja, right? Like maybe I don't have to do FA at all. Okay, let me write the command by myself. Build bin Llama server. Okay, let's type this Jinja. Let's ask it. What is the usage? So it is this. Okay. No wait. Okay, that's okay. Jinja context size of 80,000. Okay, not 800,000. NGL 99. Then we also need to use the model. So the model is models slash gamma for E2B instruct. Then the port is 8080, and then the host is 0.0.0.0. Yes. No. This is not Arduino. This can't run on Arduino at all. Arduino is not a computer. It is a computer in a way, but this is actually Jetson or a Nano that I'm using it on. But it's by Nvidia, so it has a built-in GPU. You can think about it as a Raspberry Pi, but with a GPU essentially. Okay, so it still gave us something, but I think it didn't. It probably crashed again. Failed to allocate resources for computer buffers. Okay, let's see what did this thing say. Flash attention off. So let's try that. The error is because the Llama CPP build expects flash attention FA to take a value. FA auto or flash attention auto. In the command I gave, FA was followed immediately by C. So llama.cpp interrupted. The context was value for flash attention, which is invalid. Okay, I see that. So let's try this command. It again failed. Let's try this one. So what is this thing doing different from this thing? It's turning the flash attention off. Okay, so let's say this. Okay, it's again failing. Okay. Found one CUDA device. N parallel is set to auto. Using N parallel equals to 4 kV unified equals to true. Using 8 threads for HTTP server. Where is the error, guys? Error loading model, llama with CPP lower. Failed to load the model from path to your config. Oh shit, I gave it. I'm so dumb. So I think I'm giving it. No, wait. It's the right model actually. No, it's yeah. I need to give it the. I should give it the model as well. I'm just copying the commands blindly. That's not gonna work probably. Host is 0.0, 0.0.0.0, and I need to give it the model name as well, the model path. So -m models slash gamma. So it's G. Okay, so let's try me gamma, and yeah, everything should be okay. No, wait. So let me just copy this. Okay, let's see if this works. What are the specs of the system? So this is actually using a NVIDIA GPU, and I think it has around 67 tops of performance. And then it has almost 8 gigabytes of memory RAM, and then I've installed like 128 gigabytes of SD card to it. So yeah, it's pretty decent. You can actually check out officially, because even I'm trying to look at it, but you can just check out for Jetson or in Nano, and you should find this probably. Yes, 67 in 8 tops, 8 GB of memory, 6 core ARM Cortex, and 1024 CUDA cores. So this is pretty interesting. I mean, it's a pretty small device, honestly. Okay, it's still not running. However, I was actually able to run this from just like a Llama server. I think these parameters are making it messed up. So maybe this is, what if I just run it normally without these parameters that are there? I mean, it still worked without the parameters in some way. Okay. Path to your gamma. Why does it need so many parameters? Why is it giving me that? So let's try to understand what these different are. What is NGL? What is NGL? Uh, what is NGL in Llama CPP? NGL, it should be here. Um, NGL. Okay, NGL is here. Maximum number of layers to store in the VRAM. Either it's the exact number, auto, or all for auto. Okay. Yeah, totally. I think I mean I will add that. That's a good suggestion though. Thanks. Yeah. I will add that from the next stream for sure. Yeah. Maximum number of layers to store in the VRAM. Okay, so let's set it to auto. What is it right now? NGL is 99. So let's not do it 99. Maybe like let's set it to auto. NGL auto. But I mean it was anyways auto, right? What else is available? So model, the port, host, and context size. Okay, let's run this. So this is again less, so 64,000 only. Okay, it's again failed. Failed to allocate CUDA 0 buffer of size this. Failed to initialize the context. Let me just do it without anything, without any of these parameters. So I'll just do /build /bin /llama server -m, which is the models. So models /gamma, and then the context size of, let's do 70,000. I mean, this one I think was this one was able to start, I believe, when I tested this. Okay, it also didn't work. Interesting. So what was the thing that I did in the beginning? Okay, so let's see. Yeah, I think what I need to do is I need to use this thing where I ran it with CLI. So I actually had some caching available. So I think I probably have to do that. Let me find the command. I think ChatGPT gave me that command. Yes, so I need to use that flag. So I need to use these flags. I think they probably worked. They probably worked well. So which is B and UB, right? So let's test this. B, what batch size of 128, and UB of 64. Okay. So let's see if this one works. Okay, something's happening. Okay, it still failed. Maybe let me just try it with like a less context size. Let me try 5,000. So if llama.cpp is putting too much on CUDA, reduce the GPU offloading. If that still fails, then do ngl 10. Okay, let's see if this fails or not. Okay, I think it started. So the server is available now. Um, this was with the 5,000 token window. I don't want 5,000 because it's not going to work. Let me just do one thing where I set it to 64,000 because this is the baseline. We can't go anything less than 64,000. Okay, this also started. This is pretty good. Okay, so what is the next step? So verify llama.cpp is serving OpenAI compatible API. Okay, so call this. So where, okay, 8080. So I have a new terminal here. Let me just do Q star, clear this, and call this. Okay, yeah. So we're getting some information from here. So this is probably working. You should see the model listed. Also check this thing. Let's check this. Yes, we get something. So this is probably like some initial context window, that's context system prompt that's there. Configure Hermes, run outside your current Hermes chat session, Hermes model, then choose custom endpoint. Okay, so let's do that. So let's clear this first, and then let's do Hermes model, HERMES model. Yes. So now what I need to do, I need to select a custom endpoint. So where is a custom endpoint? Minimax, DeepSeek, Google, NVIDIA, Tencent, Quen, Anthropic, LM Studio. But there's no custom model here. What is it saying? Self-hosted VVL or this. Okay. Open router, NOS protocol, mixture of agents. Um, is there anything below this as well? Yes. Quen OAuth, custom, direct API, custom endpoint. So which one do we need to select? Custom endpoint. Let's select this. And API base URL. So I think it's going to be this one, right? 127 dot this one. Let's see what it is. So API base URL is localhost, the port 8080. API key leave blank, model name, use the model ID shown in v1/model, or leave blank only if one model is if only one model is loaded. Okay, so Hermes will save this in its configuration file. So we need to just use this inside here, and we leave the API key blank. Auto detect, chat completions, responses, codecs, use responses, codecs, Anthropic messages. Okay. Use Hermes URL heuristics, best for standard OpenAI compatible. What is this about? API key model name. Select the API compatibility mode. What is that? Auto detect, chat completions for standard OpenAI compatible servers, responses, codecs, Anthropic messages. So let's just do auto detect. Yes, this is the model gamma 4E2B instruct. Context length. Yeah, let's blank for auto detect. Should we give it a context in specification, or let it do automatically? Yeah, let's at least do it. I think it would have it. Display name. Let's just do gamma 4 local. That's a good name to go with. Okay. Yeah, so it has been saved and edited in the configuration file. So we can also see this and see the configuration file of .hermes. So if I do config.yml, yes, so this is the gamma 4 model that I have. And okay, so now after this, manually config, you can also edit it directly. So I don't have to do that. Restart Hermes. So quit Hermes if you're using Hermes gateway. So let's quit this. So let's stop this. Control C. What the heck? Okay. Clear the terminal. Let's start Hermes again. Let's see if it starts with the gamma 4 model this time. Okay, it's taking some time. Yes, guys, we have the gamma 4 model running. Yes. So we were able to get the Gemma 4 running on the Hermes agent. This was, if you know before, this was running this was running GPT 5.5, but this time it's not doing that. It's running Gemma 4 model only. This is pretty good. This is pretty good. Yes. So let's test it. Hi. Uh, what can you do? So let's start with a simple basic prompt. And this is obviously going to take some time, but that's okay. So okay, it assigned 64,000 tokens. That's also okay. That's decent, but I think it's going to fill up pretty fast. Okay, it's still processing. I mean, it's going to take some time to do all that KV caching and all those things. Yeah, you see, like it's processing here. It's actually like I went to see the server. You could actually see it processing here as well. Memory sequence. Okay, reasoning budget activated. Number of tokens, 23,000 tokens have already been consumed, I believe. And I think it's still not giving us a response. Okay. Number of processes, so 0.99. Does that mean the completion? New prompt, new context slot, 64,000. Task tokens. Okay. Hmm. Has it given? Okay, yeah. The response is here. Perfect. Tell me about the model being used. So this is again 23,000 tokens. I believe it will be more once I type this prompt. Already 37% of it is consumed, but I think we can also run it till up to 100,000 to 120,000. That it shouldn't be an issue as such, I believe. You know, one more thing, I can actually run this on Telegram as well. So let's do that. And I'll actually start a new session inside Telegram. And this is me communicating to Telegram via Hermes Agent. And the main model is, you can see the model also is Gemma 4 E2B instruct. This is pretty good. And earlier, what I was using, so I'll show you. It was a GPT model that was there. I mean, if I'm able to go back up again, but I mean, yeah, that was mainly like using a GPT model, but now it's using a Gamma 4 model, 64K tokens, local host, and all those things. So that's good. Can you tell me all the? Can you list all the files inside the .hermes folder and what do they represent? Okay, so it has to do some tool calling as well in this case, because it has to read a folder and it has to read the files, and then it has to probably store them in memory and also be able to do that. But it's actually running two parallel instances in this case, so I don't know how well it is going to do, because one instance is this and the other instance is what I'm starting as well. But you could see like the prompt coming here as well, and it's processing here. So yeah, I mean, obviously one of the drawbacks of using a local model is that it's going to be a bit slow, but at the same time, it's running locally. So what else can you ask it for? Bro, even I want to build robots. Just tell me the basic coding skills and apps that are helpful to build. I'm a complete beginner. All right. I mean, with I think you just need time, to be honest. I believe that if you want to build robots, in that case, maybe start with Arduinos and stuff, and then maybe eventually, like what I'm doing right now is ROS. It's also not very complicated. Like you could still pretty much catch up. But I mean, just keep doing it. I think there's a lot of YouTube tutorials that are out there. If there's anything specific in general that you would like to know about what you need to do with programming, maybe you can ask me that. But I think maybe just give yourself 2 hours every day to figure those stuff out. I think you'll do pretty well. I mean, that's what at least I did. I mean, I don't have a background in robotics, to be honest. what is the final agenda for this stream? I mean, the final agenda for this stream is to, I'll show you the task list, is that I want to control a robot with ROS. So I'll show you the robot that I have as well. Like it's behind me charging, where everything is running. But I want to run. I want to operate a robot using this Hermes agent, and it should not use any other models. It should use a Gamma 4 model, a local model. And what I mean by running is that I give it a natural language command, for example, it to move forward, or for example, if I give it to go around and survey a room, it should be able to do that just with natural language and convert that into robotic actions and be able to do that. So a lot of these agents are being used in like software work and digital work. I want to go beyond that and actually do it on physical hardware as well to see how it performs. So I'm building towards it, and this is a list of things that I'm going to do. So I think maybe like first thing was, I think even the second thing was run, where I was able to do the Hermes agent with Gamma 4, I will actually be testing codecs as well with this thing, but I hope I answered your question in some way. I mean, it might seem a bit strange of what I'm trying to do, but like it's pretty interesting to me, and I feel like just running, being able to run robots with agents is something pretty interesting. So I'm just exploring that. Okay, let's see if it was able to return us an answer. Yes, it did. Right. So this was the answer that was given to us by Hermes, by the local model itself. I need a way or guide to just start, but don't know where to start. Okay. I mean, you should probably see what you want to do. So if you want to build robots, start with maybe like getting an Arduino and some basic sensors, and just making it work. Maybe try to make a line following robot as something that you could do to build your first robot. Then you could probably get a Raspberry Pi as well if you want more advanced algorithms to work. You could probably install some object detection algorithms and other things as well. And then I think maybe you'll get a hang of it as soon as you do it more. So I think maybe just start with something very simple, and then eventually graduate on top of it. For programming languages, I would just suggest that stick with Python. Python, I think, has pretty good compatibility for almost anything. So I think as long as you're doing that, just get the basics sorted. It's going to take obviously some time and effort. Just give yourself 2 hours, 3 hours every day for at least 2-3 months to be able to see some progress. But at least that's something that you need to give to yourself as commitment. I am also doing something similar, but digitally using UE5 and a pre-rigged character and making Gemma control it and interact with me with the game world. Okay, so I mean, do you mind telling me about UE5 and a pre-rigged character? I'm also doing something similar, but digitally using Unity NetBeans and a pre-rigged character and making Gemma control it and interact me with the game world. So, are you making Gemma for maybe control a robot, a game character? If that's the case, that's very interesting to me because I have a lot of questions after that. Because in that case, what are the parameters, or what is it that the model is giving as inputs primarily to this game engines, or if it's something else, please explain it to me, because I would be that's also a different world to me, being able to control game characters from LLMs like these. Okay. Yes. So this was done by sorry, I meant Unity. Unreal Engine was too cluttered for me. Yeah, yeah. I think maybe these engines have also gotten so good. Sorry for that, but I don't have any experience in game development yet. But I mean, this seems pretty interesting to me as to what you're doing. Maybe just Victor, if you could maybe just connect to me on LinkedIn as well. I would love to know more about what you guys are doing, and we could also have a chat more on this as well. I would love to see what you guys are doing. Thanks for sticking to the stream, by the way. Yeah. So yeah, I mean this is working pretty well. If you see that, my Telegram is working well. So that means that I could use my phone and then message it from Telegram, and the local model running on my Jetson. It doesn't need anything. It doesn't need tokens. It doesn't need cloud access, anything. I could just simply ask it to do things for me, and it could operate 24/7 without any cost of tokens or these cloud compute. And I feel like it's good for good for like a lot of jobs, honestly. Yes. So I was actually doing one thing where I was actually working with somebody, and I gave it some sort of a Reddit thread, right? So this is not sort of going in robotics, but this is just exploring the Hermes agent. But what if I just give it this Reddit thread, and please analyze all the comments inside this Reddit thread, um, make a PDF file and send it to me with all the insights. Okay. So this Reddit thread probably has 12 messages. Okay. And I mean, I could read it, but this is pretty interesting, right? Like, could it do this? Could it do this job? Could it open this Reddit link? Could it extract all the comments and as well as analyze them and make a PDF file out of this? So that's a pretty good, I would say, real world task in my opinion. And let's see if it's able to do that. And I'm just doing this from Telegram, so no complicated terminal UI. It's just a Telegram agent. Okay, Victor. It uses basic exposed input parameters within the code that handles the motion with it. Interesting. What kind of game are you using? Is it like one of the complicated? Is Are you building your own games, or are you using it in a pre-existing games? Like, are you building your own world and everything? Because if that's the case, then if you're able to make it work across maybe like any pre-existing game, that's pretty insane, honestly. um but even if you're making your own characters and your own world, what kind of inputs I think are you defining, and what kind of movements is it able to do? And I feel like there's a lot of similarity between a game controller and a robot, because I'll show you in a second where this even the robot has certain um, input streams where the LLM is giving the outputs. So for example, okay, it's given us a response. It's still doing the job, but the initial page content returned an error message from the internal agent process about a missing Chrome browser installation. Further, my search across past sessions did not find any previous context regarding how to list local models with llama cpp on Reddit. Since I cannot execute the requested PDF directly and I need to synthesize the insights from the thread, I will perform the web search using the content and then use creative director. Okay, it's still doing it. First I will find the local. Okay, it doesn't have a Chrome browser, it seems like that. Since I cannot create a PDF file, I will now search for the discussion points in the Hermes agent. Interesting. Maybe I think so. There's a way I think we can install a Chrome browser to this. Um, so if I go on search for browser control on Hermes agent, okay, browser automation. Okay, so what is this? Local Chromium based family CDP. Connect local browsers, connect browser tools with your own Chrome, Brave, Chromium, and Edge instances using Browser Connect. Local browser mode by agent browser mode. Okay. So the question is that does it not have a browser? So does this not have a browser? So we have to see that, because I think just having a browser makes it so easy for you to do extraction stuff and all those other things, that it actually becomes very practical. Okay. Uh, how to install a headless Chromium based browser on a Jetson or an Nano that can be used by Hermes agent. Okay, let's test this. Simple bean movements, and no, I do not intend to cross it over to other games. I am a newbie in game developer, but I am a 3D artist and I just got into AI too. I have a RTX 4060 and running the game. Interesting. Interesting. Alongside the game chips performance drastically, so I'm holding back for now. Along the game chips away performance drastically, so I'm holding the performance. Yeah, I can guess that. So even like it would require a intensive GPU power just for the game itself, and just using AI models on top of it would be a mess. Why don't you try using maybe like a cloud-based model in the beginning? like GPT 5.5 or a Claude Opus, and see, because these tools are these models are very good with tool calls. So and they don't require any sort of intensive GPU power also, because everything is offloaded to the cloud. And these models are again better than what you could install anyway any day on like a local computer. Why not just test it as to how do they perform even with these best frontier models? Because in that case, you could do a lot of testing in terms of how is the performance and everything. And then once you think that okay, this is pretty good, then maybe try to get like uh, maybe try to get like a local installation done of a model, and then use it. So I mean, you should be able to see something working if you just choose like a cloud based model without any GPU resources going to the AI side. So first check if it's how well does it work on like a cloud based model. Then I would suggest you to switch to maybe like a local based model, because that's why I did also here. Like I didn't start with like a Gamma 4 all the way. I just started with GPT 5.5, understood it and used it, and then now I'm switching to a Gamma 4 model in this case. Okay. The easiest way to get a headless Chromium browser running on ARM-based NVIDIA Jetson or Nano for Hermes Agent is to install a flat pack via YouTube. Since Hermes Agent is using a standard COM dev protocol CDP commands, you can hook agents directly to the browser running on the Orin Nano. Follow these steps. Okay. So what is Flatpak? Have you guys heard of this? I've not heard of this. The future of apps on Linux. Flatpak. Okay. Install the growing collection of apps from Flat Hub. Okay. Built for every distro. Works with dozens of distributions. What people are saying. What does it comes with? About. It is an independent community made up of contributors. Okay. Okay. Let's just see what Google is saying. Um, so let's install this. Let's copy the command and install this on a different terminal. Give it the password. Okay, let it do the job. So hopefully we should have some browser control as well if we're able to do this. But is it still doing it? Is it still doing the job, or is it done? Okay. Yeah, I guess it was able to do it. I apologize, but as an AI assistant, I do not have capability to create direct PDFs. I mean, it was able to do it honestly for some other person I was working with. So I'll have to see. Maybe it doesn't have the skills or tools to be able to do the PDF creation, but I think it's able to do that. Or maybe you have to give it a skill to be able to do something like that. The primary goal discussed in the threads. Okay, so this is that. Maybe let me give it one of my videos to be able to analyze. So this is one of the videos that I have. Let me get the link for this and let me give it that. Tell for so this is a podcast I did for all the questions. Give me what the response was in brief. Also, tell me the key bullet points discussed in the podcast. Okay. So let's see if it's able to do that, because I mean llama.cpp or something like I don't know if it has like internal memory or internal context for that. So it just gave me that answer. But this I'm sure it has to like probably look up the video, look at the transcript to be able to answer this question for me. Do you want to continue this operation? Yes, I do. Let's run this. Okay, password is required. Authentication complete. Unable to load summary from Flat Hub. Okay, what has it done? What did it install it finally? Let's see. So let's do apt list. I don't know what the command is properly. So but should we get the holy shit. So let me do grep. What was the name of the thing again? I apologize, but I was able to analyze the video from the provided link, indicating the video analysis tool returned an error indicating an unsupported content type. Therefore, I cannot provide you with a brief response reading bullet points discussed in the podcast. Okay, let's see. So, how can so maybe we just need the browser control. Honestly, I think once we have that, we should be able to do all of these tasks as well. So let's see how can we install that. I mean, I know this is not in the list, but like I think this is pretty important too as well. Um, let's see. So flat pack, right? So let's see if flat pack is here or not. Flat pack. Yes. So we have flat pack here. Now the question is if it's installed properly or not. That's not the question, but it's definitely there. What is the command for it? What are the other commands for it? If not exists, Flatpak install FlatHub in launch Chromium in the headless mode. Okay, let's see this. If you're using standard Ubuntu setup instead of Flatpak Chromium, connect Hermes Agent. Now the browser is running on listening to port 9222. Switch to Hermes Agent running on this window. Browser connect. Okay, let's try this then. No, it doesn't work. Okay, what is it saying? Chromium attached, not installed. So the Chromium is not installed properly. We need to install this. Let's see. Unable to load summary from remote FlatHub GPG configuration verification field, but no summary found. Dude, this default Google AI is pretty shit, honestly. This always gives me the wrong answers. Install Chromium on Jetson. Let's see this. Okay. Hope this helps. Thanks for not working for me. Okay, that's okay. Why do we need that flat pack? Honestly, it's not required. It seems like an overkill to me. Essential Jetpack packages. Sudo apt install this. Let's see if this thing works. If it's already installed, it shouldn't install. But in case if it's not, then we can install it like this. The Chromium browser. Yeah, hi Harsh. My man is here. Okay. So Chromium browser is probably installed. Let's see. Let's test this. Yes, I want to continue. All right, this is also done. Sudo apt install Python 3 numpy. I don't know. I think I already have that. Okay. Let's ask Hermes again to see if the Chromium browser is there. Can you see the Chromium? Can you see and use the Chromium browser? Use the Chromium browser. And let's give it the link to one of the videos that I have. Let's give it my videos link only. Copy this. If it's able to use it, then tell me what this video is about. Okay, let's see. Let's see, guys, if it's able to use the Chromium browser. Or what I'll do actually, if it doesn't work, maybe I'll start a new session. So let me just do that here. So let me start a new session. And in this case, let me see if it's able to do that same prompt. So I'll copy it and let me just give it to this time. Okay, let's see if it's able to do this time. Okay, what is happening here? Prepping browser navigate. Okay, it's probably going to the link. That's good. All right. I mean, one thing about that is, let's see the logs, is that it's going to be pretty worked out, right? Like, because this is a local model that's running. So, I mean, I won't be surprised if everything just crashes and stops, honestly. Okay, this is still running. Both of them are still running. Let it do this. Okay. What else? Should we wait for this? Okay, it's still cooking. Let it wait. Let us go on the list, right? Let us go on the list that we have. So run codecs with Gamma 4. So I think one of the things that I didn't add it, I'm doing it right now. Make sure have the browser control with Hermes on Gamma 4. Um, verify it as well. Okay, so this is something that's important. I would want to do, and we'll then run codecs with Gemma 4. So that's not an issue. I attempted to navigate with the navigation timed out after 60 seconds. Since I cannot access the video current directly through browsing, I can tell you what this is about. If you're a transcriber summary of the video, bro, that's what I want you to figure it out, right? Uh, video analyze. Okay, let's see if it's able to do that. I think I don't know how well is the tool calling in this case, because it gave me certain instructions to actually start the llama 4 model with certain parameters, which I didn't do. So in this case, maybe the tool calling is not that good, but yeah, that's what I'm checking. Okay, it's still not able to analyze the video from the YouTube link. um it's the same response. So probably the browser is not running in some way or the other. uh Maybe let me actually do one thing. This is a hack. So let me log into the 1.16, provided the password. Okay, come on. Oh shit, I didn't even provide the username. Bharat at the rate. Yes, we're inside. So we could clear this, and what we need to do perhaps is to check if, so we what I was thinking to do is, I was thinking to start codex only, and let it solve our problems from here. So I have codex on the terminal. So let it do the job, because I think it's a pretty decent coding agent. um so let it tell it. I was trying to install Chromium browser on this Jetson Orin Nano. I would like to run it in a headless mode for my Hermes Hermes agent. However, I it is not working. I did install the uh, browser. So please verify for me if it's working. Um, check. So let's give it the link again. For the test, for the verification, do this task with the browser. Okay, do this task with the browser. And what I want to do is that I want to give it permissions as well. So let me just copy this and do Control C, and let me do permissions or full access, and do Control V and paste it so that it can keep on working, and install the Chromium browser for me in this case. Okay. If not installed properly, please do so that Hermes can use it. Okay. Let's just give it that. I mean, it's a lot of things. I mean, it's just going to figure it out by itself, and we should probably see a summary of it when it's done. I've seen Codex perform a lot better. On the other hand, like on the than like Claude Code in some instances, in like figuring out errors and stuff like that. But it's good. Yeah. All right. So what else is there? Let it do the job. So one thing that I could do perhaps is I could actually start a GUI for this as well. So let me actually start the GUI as well. So let me open screen sharing, and that is an app in Mac that allows me to stream the GUI directly. Okay, so this you see will actually be the GUI of the Jetson, right? Yes. So this you see is the GUI of the Jetson streamed directly to my computer. So earlier I was just using terminal to interact with the computer. Now this is GUI, and why I'm using GUI because I want to actually switch gears to be able to use ROS or robot operating system now. Okay. So one thing I want to do is I want to start up ROS. Okay. So let's wait for the terminal to start. What is this? Oh no, I don't want to update the software. Okay. I mean, this is pretty slow, but it's okay because we're running a lot of processes inside Jetson right now. Yes, we're here. So let me just make this bigger so that you guys can see it. Okay. All right. So what I want to do is I first check. So ROS2 is available on this computer. So I just simply type ROS2. Let's see if it's working well. Yes, it is. So what I want to do is I want to start up a simple. So if I do ROS2 topic list, by default, there's just two topics that should come up because I've not started any nodes right now. What I want to do is that I want to start up a simple total sim node, right? So that ROS2 run total sim node. I think what is it? Total sim I always forget about it. Total sim node, yes, this one. So it should give us a window of the total that's running here, a small total. Yes, we see that here. Now if you see, so let's make this bigger. Okay, let's make this bigger. Let's start another terminal. Okay, and make this bigger as well. So if I do ROS2 topic list, I should probably see some topics. And this basically total.command velocity is the main topic that's used to sort of control this robot. What I want to do is rather, let's start a new session on our Telegram, and let's do one thing interesting. Okay, so first let's ask it what are the different MCP servers that you have. What tools are available, right? What tools are available? So let's see if it has the ROS MCP server. And why ROS MCP server is because I would like to interact with the ROS ecosystem that's running on my Jetson, and ROS is used to control robots. So now we're actually seeing that how does it do that in this case. And by the way, this is again on the local LLM. This is not using any Chat GPT APIs. Okay, let's see if Codex did any. Codex was able to get somewhere. It's still doing it. Let's see the logs of what it was trying to do. I'll verify the Chromium installation directly from this machine first, then use the loaded YouTube page transcript. Okay, Chromium is installed as Ubuntu wrapper. Okay, what is this? Okay, The page load text headless Chromium rendered YouTube page and returned the video metadata title. The screenshot attempted exposes a snap specific path issue. So I'm checking whether Hermes needs a stable executable path and a non-snap browser profile before I make these changes. The YouTube page itself is accessible in the headless Chromium, but the snap build is producing a startup warning that may not be that may not be the best thing to point an automation agent at. I'm checking for actual Hermes installation and config for clean browser package path. I didn't find a local Hermes app. Why didn't find it? The only notes and model templates are references. The Chromium snap profile exists under Snap Chromium, so the browser has to run before. I'm cleaning up a broad search and I'll check. Okay. I found the real Hermes installation finally. And local build Hermes. Next, I'm checking its browser dependency is wired. Then I'll make Chromium connected command stable for the next setup. Interesting. So what has it done yet? I'm terminating only the verification session. Then I'll retest the Hermes supported agent browser executable path. Okay. That is okay. Yes. So it can see the ROS MCP server. That is good. And it is listing us all the tools as well here in this case. I mean, it's a bit slow, but like it's okay. It's decent. It's not terrible. That is pretty good. Okay. This is pretty good. So let's ask it what all ROS topics are available. Okay. So I was able to show you the ROS topics that are available, but this is me typing the command. But I would want the LLM to discover, or the Hermes agent to discover, all these different topics that are available. Okay. So let's do that. So let's ask it what different ROS topics are available, and should probably use some of the tools from the ROS MCP server to directly interact and check how is it doing there. No ROS topics were found on the connected systems. Really? Let me check that again. Oh, I know why that's the case, because I didn't start a critical thing. I had to also start. So if I go on CD, let me clear this, and let me actually start a new terminal. Let me clear this as well. Let me do SSH into my Jetson 192.168.1.16 password. So I need to start a ROS bridge, right? Like ROS bridge, without ROS bridge, it wouldn't be able to communicate. So that's why it was not able to find anything. So let me do ROS to launch ROS bridge, BRIDGHE. ROS bridge server. Okay. Yes, let's start this. And then it should probably be able to discover all the different tools that are available. So, okay, please check again. Okay, I've given it the command, so it should do the thing again. And we should also see some activity happening here as well. Because yeah, you see the activity happening. So this is the LLM communicating with the ROS via the ROS MCP, like the ROS bridge that's there. Yes, now you see the different these are all the tools, these are all the topics that are available, and you can also see the topics here as well. Okay, perfect. So let's ask it a command, right? Let's ask it to now this is the part where it's asking, where we're sort of not controlling a real robot, but we're controlling a ROS operated you can say a simulated robot, which is this turtle, a simple turtle that I have, just to check everything's okay, and then we'll actually be doing this inside a real robot as well. So can you make the turtle move forward? Okay, so very simple command. Okay, let's test this. All right, and we should probably see some activity here, and then we should probably see the turtle moving forward as well, if everything goes well. If not, then we have to debug everything. Okay, let's wait for it. Let's see if there's any activity. Okay, it's giving it a command. Do we see anything here? Nothing. Let's wait for this to see some action. I mean, if it reports success, then it's not. I have sent the command, to move the turtle forward with linear velocity. It hasn't moved forward though. But yeah, I mean, it got publish unregistered topic, client disconnected, calling services. Okay, it didn't move though. It didn't move. Gateway interrupted. Gateway shutting down. Your current task will be interrupted. Why was that? Why did that happen? This is Rocky working. Why did that happen? Gateway interrupted. Okay. Was this because maybe let me stop this and then try doing it again? Okay, let me clear it as well. And okay, let me stop this also, and I'll run this again. Okay. But now the gateway is probably not running. So let's see if the gateway is running. So Hermes gateway status. Okay. It is running. So it is active right now since Tuesday. Yes, 47 seconds ago. Okay. So let's see if we can give the please try again. Is there a way for me to zoom this? It's probably too small for you to watch. Yes. Yes, this is better, I guess. So let's see if it's able to control the robot in this case. I mean, it did move forward, right? Like you see, it did move forward for a bit. So the connection was okay. It should probably see, we should probably see some activity here happening here as well, because this is the gateway through which everything's being communicated right now. Okay, it's still running on it. I mean, we couldn't also like expect it to do it very quick, because again, this is a local LLM model, and I mean, it's also like not comparative, not anywhere close to comparison to maybe like the frontier models by GPT or like Claude, right? Because those are maybe trillion parameters. I'm running a $2 billion, so that's like 1,000 times less than what it is. So that's okay. Okay, just come here and go on live. Yeah, just give me a second, guys. I'm just trying to figure out something. Is there a way for me to see the chat live? Yeah, that's okay. Um, okay, let's come back. Okay, it's still doing its job. Yeah. Okay, so we see some activity happening here, and yeah, it's moved forward. So it's moved forward a bit, not a lot, but it moved forward for a bit. So yes, was published successfully, and we also saw it moving forward as well. So so how much did it publish? I mean, we don't know, but I would like you to two times of what you just did now. Maybe like let's do four times of what you just did now. Four times of what you just did now. Okay, let's test this. Oh yeah, you see this moving forward? I didn't do it. All of this was done by the LLM. Okay, so that means maybe let us take off some of the more tasks. Test running ROS using the Hermes agent and install and do. So we were able to test this, and yeah, I mean, so this is Codex, maybe something that we need to do again. And browser control. Let's see where how much progress this did Codex made with the task. Okay, it's still doing the tasks for since 14 minutes now, but that's okay. Let it do its job. Yes, let it do its job. So basically, it's trying to make the browser control work via headless mode, so that Hermes agent can also look at websites like YouTube videos, Reddit threads, whatever it may be, and just makes it more versatile and more useful. Right now, it's not working that well, so that's why I've used a Codex agent to figure the error out, and it's working since the last 15 minutes. So let's give it that, and let's let it cook, let it figure it out. But yeah, I mean, we were able to, in the meanwhile, able to make the ROS MSP work and control a ROS robot or ROS simulation, this total simulation, running on our computer, right? So that was pretty interesting to see. Let me do one thing. Let me just pull out the chat actually, so that I can see it more clearly. Even my system is throttling right now, but that's okay. Uh, yes. So let's come back. Okay, I think this Hermes has done doing it, but let's see what has it done. Chromium itself is installed and work it headless, but Hermes agent browser path failed because Snap Chromium hides dash TMP, so the agent browser could not read Chromium's DevTools active port. I fixed Hermes by running Chromium as a persistent local CDP browser instead. Okay. Created local.bin.chromium headless, created and enabled. Okay, verified Chromium headless service, active and enabled CDP endpoint, agent browser, opened YouTube.this. Okay, video loaded the hidden opportunity. Yes, exactly. That's good. Okay, perfect. It did that. It did the job. It was able to like look at the. It was able to probably look at the video and do the things as well as analyze the video. So let's start another Hermes instance and then see if this thing is working. Okay, let's test. So this time it should be able to probably have browser control as well. So that means I could give it Reddit threads, I could give it YouTube videos, I could give it Twitter threads, and it should be able to do everything for it by itself. Okay, that's great. Let's wait for it to load up, and this is all done by a local LLM, not an advanced model, but a local LLM again. So let's give it a video and ask it the same prompt that I gave it before, which it was not able to complete. So let's give it this prompt. It has a YouTube video, and let's give it this prompt. Okay, so I've given it a YouTube video link, and I've asked it to give me all the responses that were there. Okay, and it should probably have all the browser control as well along with it as well. Okay, and this is obviously going to take time. This is always going to take some time. That's okay. By the way, if you're there on the chat, let me know how are you guys finding the stream so far. Do you have any suggestions? And then what is it that you like? What is it that you probably don't like that much? And yeah, I mean, if there's something that you're interested to see, I would also like to make that as well. But so far, it's going well, I believe. Okay, this is good, guys. Like, see, this was done by this, and now let's ask it a more advanced command. That's great. Make it make it do a complete circular trajectory. Okay, let's make it do a complete circular trajectory. Stop where you start. Where you start, make sure you do a perfect. Make sure that you have a good circle made up. Okay. Okay, let's do that. and it still can't do that. Why is it? Okay, let's actually do it with this thing. Browser. 1 second. So there's a browser tag that I can give to Hermes where I could explicitly tell it to use a browser. Let me start again. I think I stopped it. All right, so we're back here again. Let's give it the browser tool this time. Let's give it the browser connect tool. Wait, what is this? Browser connect, disconnect. Let's give it the is already listening on this. Okay, so I want you to use the browser. Your browser navigate snapshot and other tools are now control CDP browser. Okay, that's okay. So let's copy the command that we had here. Let me go in the command here. This is the command that I have, and I would like to come here, and I would like to use the browser in this case, and I'll give it this command. Okay, so that means that I would like it to use the browser to open this YouTube video link and then give me all the descriptions and everything along with it. Let's wait for it to complete, or let's just give it like that only. It should probably just send it. Okay. I mean, it's getting it's maybe getting a bit throttled, but that's expected because it's a pretty small model, small memory, honestly. But okay, what else is happening? Okay, it's processing. It's processing. Um, mm, okay. I mean, it's still running. Maybe should we stop it? I've stopped this now. For all the questions, give me what responses was in brief. Yeah, this was the question that I had. Let me copy it and send it again. Okay, I've stopped it in this case. Okay, let me type Hermes again. And let's give it this question. Okay, so let's give it browser. Let's see what happens in this case now. Okay, so and it's going to take some time, but let's see how has it done with the circle. Okay, that's not a very good circle, to be honest. This is not a circle at all. um why is that the case? Maybe, I think it's interesting because a lot of times when it's a larger model, or if it's like one of those frontier models, when I gave it a task yesterday, it was able to figure out everything. But with something like this local model, which is like very small in size, again, like not the best out there, it executed something like this. Okay, is there a way where we can, obviously we can't expect the same performance to happen, but is there a way where we could perhaps instill some of the knowledge by a larger model, so that the smaller or the local model can use it? I'm thinking in that direction. Maybe what I can do right now is I could switch back to GPT 5.5 and let it create a skill. A skill is just a set of text instructions that the model can sort of use. Because then, if I give it another task, if I give another model the task or the same model the task, it doesn't have to wait through to complete or look at all the steps, right? So maybe that is something that I can do, because right now it's not performing that well, because there are a few hidden things that are always there in any specific task. For example, even if I say that do something in total sim or do something in a robot, there's going to be specific things that it needs to be doing, it needs to pass on, that it has to figure out. Maybe like a smaller model couldn't figure those things out, and that's okay. So what we could do is that we could ask a larger model to figure that out for ourselves, and then we can maybe probably do that. Okay. So this is still running, and yeah, all the slots are idle. Number of tokens 28,000. What I should be doing, maybe let it cook, let it work. Let it work. Okay. What MCP tools do you have? So in this case, what I'm trying to do here is now, can this can this much more advanced codex model help instill some of the knowledge of maybe tool usage or how to use ROS and everything, and instill that inside a skill that a lower model, for example, the Gamma 4 model, can use. Okay. So I'll ask it what topics are available right now. Okay. Now basically I'll ask you to do the same thing now and then see the difference. So this is what happened when I asked it to make a circle. And this is the circle that it made. Like the last thing that you see, that is the circle that it made. And it's not a circle, obviously. I'll do the same thing here as well, where I'll ask Codex, make a complete circle of the turtle, from the turtle. Stop where you have started. Okay, so let's try that. This should always be fast, and like this should do the job for us as well. Now let's see how does Codex do the job here in this case. Okay, so this was actually done by Llama, running locally, Gamma 4 model, and now you see this is Codex doing its thing, and it will make a perfect circle. It made the perfect circle. Yeah, because this is again like a trillion parameter model, and I'm using what, a 2 billion or 2 billion parameter model. It's not going to be comparable. Okay, but the question is, or the unique thing that I could do right now is I could ask it to instill this knowledge that it had, and basically I will then ask the other model, which is the Gamma 4 model, to use the knowledge that it has instilled to be able to do something similar. Okay, that is great. Um, you did a good job. You did a good job. Can you instill controlling total sim or ROS total sim into a Hermes skill that even a smaller model can use to be able to execute the command as the same degree as you did. So let me give it some context as well. The Gamma 4 model on Hermes produced a terrible final output when I asked it to make a complete circle. One second, guys. My mom is calling. Hi, guys. Sorry. So yeah, just to give you a bit of context, what I'm doing here is basically this codex is able to do a pretty good job in controlling robots, but I need to. The smaller model is not able to do the same. So what I'm trying to do here is I'm trying to instill what the larger model did, the codex model did, into a skill, so that that knowledge can be used again by a smaller model to be able to do the same degree of work. Okay, it's still writing the skill. That is good. And then we'll see if this skill sort of makes any difference in terms of the output that the models are generating, right? The smaller models are generating, because if you're able to get the level of response or the level of output from a smaller model of what you were getting from a larger model, then they pretty much solved a lot of things in that case, right? Okay, let's see what is it doing. Let it do the thing. Okay, let it do the thing. By the way, I see three people. So if you have any questions, let me know. In the meanwhile, it's doing. Maybe I can answer some of the questions that you have, or any thoughts that you think about the stream, about using Hermes, etc. I would be very interested to know. And maybe I could also turn this on so you could see the comments here as well. Yeah. Okay, so it seems like it's still doing the thing. Uh, all right, Victor is asking us a question. I am actually modeling, and this is a really good background information noise for me. I'm actually modeling, and this is really good background information noise for me. I mean, yeah, it's good that you find it useful. So, are you using this? Are you using this in modeling? How are you using AI right now in your sort of domain, Victor? And thanks for being on the stream, actually, Victor. So that it actually helps me a lot, because I could see somebody live watching, so it's not me who's a mad person just doing this, but somebody else is also watching, so that helps a lot in just keeping the stream going. So I really appreciate you sort of taking out the time for watching this as well. By the way, where are you from, Victor, if I may know? Okay, let's see if this is still doing. I'm just waiting for it to create a skill. I mean, it shouldn't take so much time. It just has to create a text file, honestly. I don't know why it's taking 3 minutes or 4 minutes already, but I hope it does a good job here in this case. Okay, it's created the skill for us. So we have Geek Bros here. Hi, hello. I like Sheldon Cooper. I use it for not too much, but for some personal health and investment plans like in stock matter. Yes, that's good. I mean, yeah, I mean, you could maybe I was actually working with somebody yesterday, and what we did was we installed Hermes Agent. So right now, maybe a Hermes Agent on. We purchased a virtual machine, so that that machine could run 24/7. We installed Hermes Agent on that, and then this person, he was not very technical, but he did almost everything, offloaded all the tasks with it. So it becomes a different beast when you could just run it 24/7, because in that case you could give it any task and it just figures out by itself, right? And Of course, if you run a good model on top of it, it just is cherry on top on that. But but I see that if you run 24/7, it just becomes very useful. So yeah, I mean, just maybe if that's something that I'm also trying to automate, where I could just let it run 24/7 and let it do any task that I wanted to do. Okay, so has it created a skill for us? Can you explain what you're doing? Robin plays. Yes. Let me give you a brief of what I'm doing here. So I started off with so I'm right now installing. I've installed Hermes Agent. If you've not heard of it, it's like OpenClaw but better. And basically, I was able to get some good responses using a GPT model. But today, what I'm doing is I'm trying to use a local model. In this case, the model that I'm using is a Gamma 4 model, and in and basically I'm trying to use Hermes Agent using that local model. And there are few performance issues that I'm facing, so I'm just trying to fix that. So one of the things that I'm trying to do with the Hermes Agent, with running in the local model, is let it start up. So this is the GUI. One second, it has not there, but basically I'm trying to control a ROS operated robot uh, using Hermes Agent that runs a local Gamma 4 model, right? So that's what I'm trying to do. And basically right now what's happening is this is one of the best codex models that's there, and it's sort of instilling the knowledge of how to control ROS robots into a skill that then the smaller model can then use, right? So yeah, it's done that. So it's instilled a skill, and inside skills slash MCP total sim circle control skill.md. So I didn't want it to do completely circle. Maybe so let's ask it to change that. um, okay, and this is the GUI that I was talking to you about. Yes, so this is actually the GUI. I'm controlling it inside terminal. Okay, so what let's do one thing. Let's So what it did is just total circle control. So let's see how well it did. So let me start it again. Let me do Control C to stop this, and let me start Hermes again. And Victor, okay, let's see this. Do you think that the context window problem can be overcome with maybe contexts that can be quantized and offloaded onto storage unit, and the GPU hardware can call these quantized instances as a RAG? Let me read your question again. Do you think the context window problem can be overcome with maybe contexts that can be quantized and offloaded onto a storage unit, and the GPU hardware can call these quantized instances as a RAG? Probably yes, I think so. One of the things that you should know, that I'm also using a quantized model at this case, right? So this thing is a quantized model. It's a Q4 quantized model that I'm using, and I've not quantized it myself because I don't know it. I'm using a unsloth version of this. And this is actually a pretty large model. This is actually a 5.4 billion parameter model. What And it has been quantized down to 2.1 or 2.3 billion parameters. So again, you could say that I'm using a quantized bridge, but I maybe let me try with a bigger model. I don't think it can support that big of a thing, but I think there's truly a limitation on what you could do, right? So I think there's even more. So I that's a very interesting you do it. Um, so if you this is the exact model that I'm using, and if you go on files and version on this, you see a lot of quantizations that are available. There's a Q4, there's a Q5, there's a Q6, Q8, right? I think Q8 is the bigger one. So Q8 is like 5.5 GBs, Q5 is 3.36 GB. What I'm using is Q4. Um, yeah, what I'm using is Q4. That's maybe like 2, 3 GBs. But I think yes, you can maybe like you use a larger model, obviously with the quantized version as well. But again, again, there's I think yeah, I mean, it works well, honestly. So if you have good hardware, then obviously by all means you can use like a larger model as well. But yeah, I think maybe I can't run like 100 billion parameter model in this case. There's truly a limitation that is there even with quantized version. But I think that's a good point that you raised. I think yes, totally you can do that. What do you mean by these quantized instances as RAG? I didn't understood that. Yeah, I think just explain me that. What exactly is that exactly? And if you have any links for this, also, I would love to check it out because it's the first time I'm hearing about this. I would love to learn more about this. Okay. So let's ask it what skills do you have available? What skills are available? So Codex created a skill for us. So let's see if the skills are discoverable by Hermes in this case. And this is going to take some time. That's okay. And you see that the tokens are being used here. The local model is being used here. Let's wait for it to completely become available. I mean, it takes some time to even like initialize everything and like give us an answer to even stream the response back. I think maybe the streamable version is not on. That's why we're not able to see the stream version. So we'll see everything all at once. I mean, we can just wait and watch. Okay, it's doing something. Okay, Victor. Every time the engine instantiates, it uses these rags. It uses these rags from the previous chats to attract only relevant data. Okay, so you are essentially somehow storing all the previous chats. Okay, so if I understood it correctly, you're storing all the previous chats in a vector database, and then as soon as you want to perhaps retrieve an important thing, for example, if I say to do, if in a previous chat I ask you to do a certain thing in a certain way, then you're retrieving the previous chat from using rag and then using that as context on top of it, so that the model doesn't have to figure everything from scratch all the time. Is that what you're trying to do? Let me know. Okay, I think now I understand why it took so much time, because I mean there was like millions of skills that are there. So it was probably trying to load everything in context and get it to us. but I think we should have asked for a specific skill rather than like just asking us rather than asking what the skills are. But okay, now we'll actually see what skills are available with what skills all skills are available with the Hermes agent in this case. Okay, I think it's completed the response, but let's see what skills are available. Okay. Yes, and hence cutting down the context window build up the enabling much bigger models to run on a smaller VRAM. Yes. Yeah, I think these are good techniques. These are very good techniques where you could use quantization, you could use context. I think this also comes under context engineering in some way or the other. And it also comes in reusability of different things. But I also think that there has to be a way where knowledge is also dictated by the quantization of it. Maybe I'm not very technical yet on commenting on it, but I believe that if you quantize it too much, then the performance sort of degrades, even if you do good context engineering in a way. But I would love to know more about this thing as well, where what would be the performance impacts of probably doing these optimizations on top of it, or if you do these optimizations, do you get similar response, or do you get do you get a similar quality response from both the things? Maybe using a bigger model or using like a smaller model with perhaps these optimizations and things that you built in with it. Let's see. Okay, so these are although I mean we might be deviating a bit, but this is interesting to see because these are all the different skills that the Hermes agent has. So I think somebody was asking in the beginning is what exactly is Hermes agent and why is it useful, and I was trying to explain, like Hermes agent is this thing with persistent memory, but what actually sets it apart, I believe, is this only, where it has all of these skills that are available that comes inbuilt with it and it's able to use it at a continuous basis, right? So you see, obviously these autonomous AI agents, it could do all these videos and everything, not very interesting, but it can probably access your emails. It has all these MCPs. Okay, what exactly is in media? So YouTube content, YouTube transcript summaries, threads and blogs. Research, it can do research for us. UGV rover setup. Okay, that's interesting. Yeah, we also made that into a skill yesterday, and so I think one of the skills that are not there is, do you have a total sim skill? Let's ask that just let's see this. Hmm. I think yeah. I think Google has made some investigations on this as they shrunk down. TurboQuant is a post-training vector quantization algorithm introduced by Google Research that compresses the KV cache of LLMs to 3-bit without requiring training or fine-tuning. Very interesting. I'm actually doing one thing also. I'm also reading papers on stream. So let me just get done with this, and I'll probably pull up, because I'm very interested to learn more about these things. So I would probably hook up some papers or look at some articles and do it live on stream as well. So I think it would be very interesting to learn more about this, because yeah, because a lot of times you just like do the most expensive thing, run a GPT model, but a lot of times quantization and all this optimization comes in a lot more handy. So yeah, that would be very interesting to learn as well. Thanks for letting me know on this. Yeah, thanks, Victor. Okay, it's doing that, and that is lossless, by the way. Okay, that is pretty interesting. How if you've read this, or if you know more about this, let me know how they've what is the quantity, what is the quantitative metric that they've measured lossless, so to say, right? Like, what do you mean by lossless? So do they perform, do they have a benchmark where they make these LLMs perform with like optimized, non-optimized ones? So is the performance the same? And like I would be interested to know more about that. And just so in that case, let me know on that. Okay, so I've asked it, if do you have a total sim with you, skill with you. Yeah, sorry for that. Codex created that skill for us, and we should probably see that. And it takes some time because this is again running locally, right? And you can see it in action. And this is, I think, not being streamed. I don't know why it's not being streamed. So if it was streamed, we could have at least saw something. But I think it's waiting for the entire response to be completed. No, I think it is being streamed, honestly. So let's wait for it to complete. Okay, I'm going to be back in a second. Let this thing complete. I'm gonna just let it be there here. So I'm just gonna come back. Hi guys, sorry for that. I just went to have some water. Okay, so it has the skill for total sim. This is amazing. Now, now what I wanted to do is that let's see if it is able to discover all the ROS topics that are there. So, can you tell me all the ROS topics that are available? Okay, let's see this. So it should probably be much smarter in this case now because it has a skill. I wouldn't be specifying. I shouldn't specify, but just to say, okay, yes, okay. It is able to see all the different ROS topics as well. Okay, it's gonna take some time to load up, but yeah, it's there. Let's see. Let's log in here. Okay, so this is the main GUI of the computer that I'm streaming you via VNC server, so that I can also see the total interaction as well. But okay, now the next thing that I want to do is that use the skill to actually make a complete circle. I mean, okay, so first of all, these things, they're not meant to say that robotics is here or generalized robotics is here. But what I'm just doing is checking the connections and how even on these simple tasks, how do these LLMs perform, right? Because if I were to say to maybe, for example, do a long horizon task, it can't do that right now because it doesn't have it. Let's see if it's even able to make a circle in the first place, right? So I mean, those are some of the pre-existing things that are very important to do. One second. Sorry guys, I'm back again. Just had to do some work in home. Okay. Use the skill to actually make a complete circle. Let's see if it did that. Okay, so the GUI is not coming up. Okay, it's there. All right. I don't know if it made a complete circle. Let's stop this and let's start another total sim node. In this case, to see if it's working or not. Um, let's run a total sim node, a fresh total sim node. Let's see. Let's see how does it perform then. Okay, so make a complete circle now. Okay, let's see how does it do then. Huh. Okay, and we should see some activity also happening here as well. Yeah, we do see that activity happening here as well. Okay, and there's the movement here still, so let's wait for it to complete. All right. uh okay, Victor, YouTube is hiding the links I post here. I put up a research papers for turbo quant before this, by the way. All right, I've noted it down. Turbo quant, right? Like I'll probably check it out as well after the stream, and let's do like let me do like a proper stream where we'll just explore this thing. Like we'll explore quantization, we'll explore turbo quant, and all those things, because I'm very interested to know about this. And yeah, just if possible, just message me on LinkedIn as well. Maybe if there's any specific things I want to ask you, maybe I'll do that there as well. Okay. The tool calling failed because the action type does not exist. This is pretty dumb. Um, okay. So why didn't it use what ROS topics are available? I mean, this is again not very interesting stuff. I know, guys, but like it's still like I'm trying to see. So these are some of the things that are not very smart. It's not able to exhibit any intelligent behaviors as such. But let's hope if we can make it work somehow. It would be pretty interesting to see. What else is there? Okay, the available ROS topics. So it's able to see the ROS topics. What I'm wondering, what does the skill even say? So what was the name of the skill? Let's give it the exact name and see if even then it's able to do it or not. So use this skill, total sim control skill. Okay, let's do this. Let's do this. Let's see how does it do it here in this case. Yeah. Still there's the movement on the total. Okay. We could just wait for it, although we don't see any streams of things happening here as well. So let's wait for it, because I mean it takes some time. Although what we could do is that I'm seeing that as the longer context size builds up, it just becomes it harder and harder, or maybe it takes us more time. But that's expected, I believe. Okay. This is the ROS bridge that's running. All right, let's look at the task list that we had originally and where are we right now. So Oh, so we are still here running ROS on Hermes Agent, operate and do all the tasks on a real robot. So we might not be able to do that today because we're still on this technically where we are still testing ROS. But we can do these things for sure. Like we could check running codecs on this. Let's do that. Maybe on a different terminal. Let me just do that while it's doing it. Let me just open up a new terminal. So this is a new terminal. Okay, it's here. Let me also SSH into this 190. So one second, we should find the command. No, Bharat. So that's my username at the rate 192.168.1.16. Let's provide the password. Should ask for it. I mean, I think even the Jetson is sort of throttling right now because of so many processes that are running. It's kind of like truly like just pushing it to the limits, honestly. Okay. Yeah, this is very slow. Like, I mean, I don't know how to check it, but I'm sure there's quite a lot of processes that are running right now, and it's gotten really slow. Like even these movements are not happening. So I don't think I can run another Hermes client on it right now. I mean, that's one thing that you see, right? Force exiting. So it's difficult to run local models like as real time as possible. But I mean, I think you need to also see and optimize for the tasks that you're trying to do. And I think that's what I'm doing. I mean, the installations are easy, not that hard to be honest. But again, I think the main thing that takes time is all these different optimizations that comes with it, and just seeing what are the limitations of your device as well. But I'm also still learning here in this case, like just trying to understand what's happening here, a lot of things. Because even if it can't do a simple circle, it would have a really hard time controlling like a real robot for sure, for sure. But I'll have to see that where what is working, what is not working, because I see that a lot of things are working, but not a lot of things are working as well. So the good thing is that it's still not did sudo or force shutdown, so that's good. That is good. That is a good sign. And you see like how much time it's taking for this. But yeah, I mean, I think still it's not bad. I would say not bad at all. um Cancel task, slot release, stop processing. All the slots are now idle because we stopped all everything. Okay. So now in this case, this is using a fresh context window. um Let me say, what was it? Yes, this was the last command. So we just give it this. Let it do the let it let it let's wait for it to complete. Okay, it's still doing the thing. Do we see anything here? Saving prompt with a length 33,919, total size 226 megabytes. Um, I believe it's still doing it. And we don't see anything here. Nothing. Okay. You okay? It's doing something. Okay, it stopped. It killed. Okay, I see. Maybe let's run this again because it stopped now. I think it should also fail then Hermes Agent as well. Waiting 6 seconds before the last removal connection. So, guys, the last Hermes Agent, sorry, the Llama, our local model crashed, and we've restarted it, and that was kind of expected because it was getting very slow and like very. I think it just built up a lot of context bloat, so to say. That's why it was not working that well. So let's wait for it to initialize again. Let's do some research while this is happening because it's going to take forever. Okay, it didn't take forever. Okay, it again failed. Okay, why is that happening? Because it's the exact same command. Wait a second. um Let me do 50,000. All right, so at least the initialization has been done, and I think server is listening to this. So I think the server has started. Let's see if it's started again. Try again. Okay. I wanted to do more in the stream, but I think it looks like there are a few issues that we need to fix before that. One of them being let's note down those issues, right? Let's note down some of the issues that we are facing right now, and that's as expected because I mean issues will come. So one of the issues that we are facing is the Gamma 4 model is not able to control ROS, is not able to give instructions um, properly to be able to is not able to give instructions properly to be able to make a to be able to complete a full task. What else? So the Gamma 4 Llama CPP build is unstable, and sometimes it crashes. We need to find a way. We need to find a way where this can run robustly long enough. Long enough. Okay, what else? Um, Check what is the correct correct context size for the same. Make sure. Okay, I think this is good enough. Um, Meanwhile, it's doing it. Okay. Based on the available tools, it's most likely the thing. Since I lack the exact implementation, the details of the skills I will have to implement, I will start by this. It's still doing the job. So let's see if it did something. Let's wait for the GUI to load up. Yes. No, nothing. So it did move. It did change its orientation, if you see, but nothing concrete yet. It didn't perform the complete task. And the reason that I'm doing this simple tasks is to see even if it can do these simple tasks in the first place, right? If it can't do these simple tasks, it can't do more complex tasks at all. So no, it's not able to do it. Okay, is it still in the process? I will perform step 1 and 3. Let it do it. Let it do it. Let's search for the Kimi K model, right? Like Kimi K model. Okay, because this is the model that I wanted to install, and I wanted to see what it can do, what we can do with it. Okay, so what I want to see is that give me so there was this website on Jetson AI Lab. Jetson AI Lab. Let's go here. So we should probably see all the models that can probably run on this thing, right? So if I go on models here, yes. So you see all these different models that are there. So these are all the models that I can run. I think they have been tested properly for the Jetson devices. So and they also have the benchmarks here as well. I don't have these devices, but okay. So what models are there? Google Gamma 3. That's what I installed. Google Gamma 4. What am I using? Is it Gamma 4? Is it Gamma 3? It's Gamma 4, right? Yeah, I just forgot about it. It's Gamma 4. Um, okay. So we have Alibaba Quen 3, GPT OSS, Meta Llama 3, Quen 3.5, NVIDIA Cosmos Reason, NVIDIA Nemotron. Okay, so what exactly is the Nemotron model? So we have a 4 billion parameter, 30 billion parameter, 9 billion version 2, 12 billion VL, and Nemotron Nano Omni. So what I'm interested in is seeing these two models. Let's look at these two models, and also, um, so what is what till what size till what parameters can LLM model can I install with Jetson or Nano? Okay, let's do this. Let's search for this. Uh, 3 to 7 billion parameter range. Okay, so this is pretty good. That means a lot of models could actually fit in here as well. Hmm. Okay, what is this one? This is okay. So this is the Nemo. This is the model by Nvidia, Nemotron 3 Nano Omni, and I mean you can't run this on the Jetson or a Nano 8 GB model. It's not even showing me that, but I can run this one, I believe, Nemotron Nano 4 billion. So what are the effective parameters here? Interesting. It's on a nano 18 tokens per second. So I think we were getting around, what is the context size of this? Context length is 256K. That is close to GPT 5.5. I think this is more than GPT 5.5. So does that mean that I could run 256K model on a 8 GB device? That's going to be pretty insane, guys. Like I would love to try this out. Um, and yeah. Okay, so let's actually do one thing. Let me actually save this, and we'll actually be using this as well. And what else? What other models do we have here? Let's see if we did any progress in the tasks here. I have captured the post, but I need this treat this as a starting point. Okay, is there a tell me what the skill has, and the skill has. It may also have a Python file. It may also have a Python file that you can use to make a complete circle. Okay. I mean, this is again pretty dumb, but it's okay. Oh. Let's do one thing, right? Like, let's just give this to one of the Hermes agents and ask it to see what models can it run. Like, why not just use it to the full extent? I mean, if it's not able to do this, I don't think it will be able to do anything else apart from this. But let me just give it this. Give me a list. This contains the different models for the Jetson devices. I would like you to go inside each model and check if I can run that specific model on the Jetson or in Nano 8 GB device. Also tell me what is the context size that I can use and the number of parameters that comes with it. Okay. And please export your research in an MD file inside and put it in desktop. Let's give it some task to check and give us a list of all the models that are there and complete an end-to-end task for us. In the meanwhile, let me just also see what the Hermes agent did. Okay, let's see. Let's see. This is not working, or is it? Yes. Yes, it did a complete circle, guys. This was done by Gamma 4 model. However, it was a bit of cheating because it didn't thought of its own. It used a Python script, a predefined Python script, and just ran that Python script, and that actually made a circle. Not it, but it still was able to make it work. I was still able to make it work with all the prompting and everything. But I think there's still a long way to go for it to actually control real robots and make it work. We'll have to see. Okay, so if this doesn't work, then what I can do is I could probably test it on a different model, because probably Gamma 4 would be a good reasoning model, but it's not the best tool calling model in my opinion. Just checking on this experience. So maybe something like that's more coding oriented could be a better choice for a task like this. Okay, so and let's ask it that as well. Also tell me if there are certain models that are better in coding slash tool calling tasks. Pick the best choice for me. Pick the best choice for me to control ROS robots, right? So let's also give this thing as well. But this is pretty good already. But these are all the models. I've given it a job to be able to complete this. What I could also do, I could just actually do it on fast mode as well. Okay, so now this time it should probably do it quickly. Okay. All right, it's still doing the job. What I wanted to see if I think this is done. Maybe I wanted to see if can you can you start a codex session with the Gamma 4 model and create a static HTML page for a for a catalog of the various AI models. Let's see how does it do that. Store this in the desktop. Make a folder and store this. Make a folder and store it in the desktop. Okay. I've given it some tasks. Let's see how does it do that. Do it in that. And I've also been using. Okay. Okay. So it didn't work properly because llama.cpp is only I've only initialized it for 50,000 tokens, but I think Codex would need 64,000. So let's change it to maybe like 70,000 and then try it out again. I hope it doesn't crash. Okay. So I think it has started again. And what I'll do, I'll start Hermes again so that everything is refreshed. So there's no cache as such that's there. Okay, let me start Hermes. But this time it should start with a larger context size, context window. So let's not keep it here. Okay, all stalls are idle. So maybe it should occupy one slot. Okay, perfect. So it has started. Does it have a, yes, it has a, this thing. Please make a folder on desktop for all the file. Make sure that codex does the job end to end. Let's do this. Let's send it. Okay. Okay, we can see that it has started to process. I mean, it's not the fastest model in memory, but like it's still working. And it's already consumed like a lot of tokens, honestly. Codex will consume other tokens. Let's see if our research task was done or not. It's still work in progress. Um, It's still work in progress, and I've given it a fast. So this consumes the maximum tokens speed, the fast and the extra high. Hmm. Hmm. Okay, both of the things are happening right now. Let's keep it here so that we can see it. I have enough data to write the file. I'm going to create a markdown report on the desktop to full model table plus a short recommendation section for ROS and Hermes control. That is pretty good. By the way, guys, we are at 3 hour mark, so we've done with our goal. It was truly it's the biggest live stream I've ever done till now, but it's pretty fun to do it here as well, man. Like it's so interesting. Thanks for the one person that stuck around for the longest, and the 2 3 people that were watching. It's amazing to see you guys here. Okay. So it should probably write up a markdown file inside desktop. So let's go there and see if we have the file here. Okay. Do we have anything like that? YouTube videos? No, nothing yet. Um, yes, there is one, right? Like ROS MCP normal notes. No, that's not the one that I have. Let it wait for let's wait for it to complete. While meanwhile this is doing something. The only question that I have is that is it using codecs or is it not using codecs? Like if it's not using codecs, then there's no point. But let's see even if it can do something like that as well, even if it can do anything practical with that matter of fact. All right, so the research is here with us. So let's do one thing. Let's actually import this on. Let's first cat this to see what is there. Jetson. So this is the research that it did. It's pretty good. Let's see. Let's do one thing. Let's actually copy this to our desktop, our own desktop, so that we can see it. Let me open a new terminal, or one is here as well. What is this? Okay. So what is the command? SCP. Um, SCP command to copy from remote to local. Okay, so just the IP address and the user ID. So Bharat at the rate 192.168 1.16, and then what is the file that we want? We want it inside that's present inside the desktop, but we don't have to type it ourselves. Let's do it. Desktop, and then what is the name of the file? The name of the file is this. So we should copy this, and we should probably paste it here, and then we actually need it inside our own desktop. Okay, password. The file is here. Let's open desktop. Let me actually do one thing. Open Jetson CD desktop. Open Jetson. So let's see. Okay. All right. But this still doesn't open with VS Code that I want it to do. So let me just minimize this. When we come here, and where do I have the file? Where is the file here? The file is here. Jetson AI Lab. Open with. Okay, I remove VS Code. No doubt about that. Yeah. So yeah, it's not going to work probably. What I need to do rather is I need to close this and put this here, and I need to probably commit here. So this is all the research that's done. I mean, it's a lot of. So let's do one thing. Let's actually copy this and come on Safari, and let's do Markdown Visualizer. Okay, Markdown live preview. Let's paste it this. Yes. So this is the live preview that we have. And you see, this is all the research that the Codex agent did. And these are all the models that we could use on our Jetson or Nano. All right. Does it have any recommendations? Best choices for Hermes ROS control when 3.54 billion parameters with VLM on or a Nano 8 GB. Okay, that's interesting. Very good. Gamma 431B, Jetson or a Nano. Can it run it? Yes. No. 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 Okay. So yeah, I mean this is a pretty good suggestion. Basically what I asked it to do was to just go through this website. It has like, this is the Jetson AI website which contains all the models, and I just didn't knew which models had were supported in for my device. So I just gave Codex a job to be able to find out all these models, and I have this in a markdown file. So what I'll do, I'll rather in my next live streams, I'll actually test this on to see how does it perform in one of these models, because Gamma 4 is not performing that well. I mean, you guys saw it, right? Like where I mean, this is the GUI. So let me just open this. I mean, it's not able to perform proper tasks on this, so it's not going to do any good. It's not being able to do any good real world tasks as well. So let's leave it like that. But see, okay. So is there anything happening here? Okay, I think it did it right. Like, let's see if something has happened here. LS. Um. Okay, what is the file name, folder name that it's used? AI model catalog. Okay. Yeah, there it is. So there it is. So maybe what let's do, let's see what is the output of it. What is the quality of the output? Maybe what I'll do, I'll actually SCP it again. Uh, hmm, okay. And then what is the name of this? AI model catalog. Let's copy this to our desktop, and yes, let's give it the password. Okay, it's here. So let me open this. Open AI model catalog.html. Yes. So this is created by Gamma 4, guys. This is created by Gamma 4. I mean, pretty basic, but not very basic as well. Like it's a catalog at the end of the day. So this was created by the Hermes Agent and by Gamma 4. So we'll probably do some more complicated stuff as well, but this is pretty impressive for what it is right now. And at least it did the job, right? One thing that I'm not sure about is, did you use Codex? Did you use Codex for this task, or did Hermes only did it? Hermes only did it. Let's see. Let's see if I mean, I'm not sure, because it looks like it didn't call Codex at all. But if it did, that's pretty good. Although I said it for it to do it, but let's see. Your task was executed by Hermes reasoning capabilities. Um, okay, so it didn't use Codex. So we didn't achieve a lot of. So we didn't achieve that goal as well, where we wanted it to where we want Codex. We wanted Codex to be able to use this, but that's okay. Um, we actually got something done using long horizon task, but not done through Codex. Just normally before this on local LLM. We need to probably do these other things as well. But yeah, that's good. All right. Okay, I think I'll wrap the stream here, this one right now. Maybe I'll do another stream today. But thanks, guys, for joining. This was perhaps the most longest and most watched stream for on my channel. Thanks for sticking around as well. And I really appreciate you guys coming here and just watching me do this. And I believe, like, also the inputs that you give it, the comments that you guys do, it's very amazing to like work around with it, and it's just more engaging to do it as well. I will bring out more better content on this, and we'll do something interesting coming forward. Okay. Thanks. Have a nice day. Bye bye.